All right. Good evening. You're welcome to today's lectures. Today we'll take a look at physics. 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 Okay, so in our last class, we concluded with the linear graphs, okay? The velocity time graph and the deductions from the graph, where we looked at the how to calculate the distance covered as area under the what? The curve. Can you remember? We solved many questions there. So today we move to something still under motion, but we'll take a look at the equations of uniformly accelerated motion. Equations. That's the next thing we are going to look at based on your syllabus, okay? Equations of uniformly accelerated what? Motion. So what I will do is that we'll just take a look at the equations and possibly see how far we can go with the derivation, okay? Just look at the derivation, because if you don't understand how a particular equation is derived, you will know when to use it. In fact, you may end up just cramming it, and if they twist one or two things, you'll not be able to answer the question because you really don't know where it came from because you just crammed it, okay? So basically, I'll outline the equations. There are three equations. I'll outline them then by the side. Then I'll derive all of them. Then after that, we'll now go into calculations, okay? That's what we'll do under this topic, okay? So the first of the equations, the first one states that, okay, our topic is what? Equations of what? Uniformly accelerated what? Motion. I don't want to go into start defining uniform acceleration again, uniform velocity again. Please, we have done that. And the lectures are there in YouTube. You can watch the lectures. Let's go straight to what we have. Let's go straight to what we have. So the equations are: number one, V is equal to U plus AT. Number two, S is equal to UT plus half AT squared. Number three, V squared is equal to U squared plus 2AS. These are the three equations of motion. Number one, V is equal to U plus AT. Number two, S is equal to UT plus half AT squared. Then number three, V squared is equal to U squared plus 2AS. So I want to see how these things came to be, okay? So let's leave it there and come over to this side. Number one, let's look at the first one. You know, from the definition of, for the definition of acceleration, we say that acceleration is what? Change in what? Velocity per unit time. True of us, change in velocity over time, taking for that change, okay? So basically, if that is the case, of course, you know that, in fact, let me define these parameters. V is equal to what? Initial and final what? Final. Are you following? If you are lost, please ask question. Don't keep quiet, okay? V is what? Final velocity, okay? And U is what? Initial velocity. Then S is what? Distance. T is what? Time. Then A is what? Acceleration. Okay? A is what? Acceleration. So let's look at let's prove this thing. Let's look at number one, first equation. First equation. Look up. From the definition of acceleration, we said that acceleration is what? Change in what? Velocity over what? Time, right? So what it means is that the change is simply the final velocity minus what? Initial what? Velocity all over what? Time, right? From these parameters, acceleration is what? Is what? Is what? From the parameter I listed, now acceleration is what? So A is equal to what? V minus what? U over what? T. This V minus U means change. That is the final minus what? Initial. Are you following? All over T. So this is the definition of what? Acceleration. From here, this first equation is simple. Simply make V, which is the final velocity, the subject of the what? Formula, and we are good to go. So this implies that if you make V the subject of the formula, we have what? We have what? Make this V the subject of the formula. Okay, let's not waste our time. Since I jumped a step that will confuse you. So here simply means that V minus U is equal to what? True of us, we cross multiply, right? V minus U times 1 is equal to what? A times T, right? Which is what? AT. Are you there? V minus U is equal to what? AT. So V is now equal to what? Huh? No. If V minus U is equal to 80, if X minus Y is equal to 2, what is X? What is X? Huh? You don't know? Are you serious? If X minus Y is equal to 2, what is X? Are you serious now? It's not X is equal. This one go to this side now. True of us. This minus X minus Y will cross over the equality sign. It becomes plus what? The sign will change to what? Plus. So if the sign changes to plus, it becomes what? 2 plus what? Y. Or it can be simply S equal to Y plus what? 2. It's not. So come to this place now. If you want to make this V the subject of the formula, minus U will come over to this side. It's not true. So if minus U comes here, it becomes what? AT plus what? U. You can write it to be in this form. V is now equal to what? U plus what? AT. Is that not the first equation? Eh? That is the first equation, the first one. Any question here? Eh? Okay. So let's go to the second equation. Please, I need maximum attention in this second one. It can be confusing. So you really need to be, be very, very attentive while I drive it fast. Put down so I can continue. Are you done? Good. So let's go. So I can clean here now, right? All right. Okay. So let's go to the second equation. This one. This one. We need some things from here to be able to derive this second one. Let's go. From the first equation, V is equal to what? U plus what? AT, right? Good. You square both sides. Square this side and do what? Square what? This side. So square both sides of the above the equation. That is equation 1, right? So if you square both sides, that means here will become what? V what? Squared, which is equal to what? U plus what? AT what? All squared. That's the meaning. Okay? If you square the both sides, you expand this bracket. If you expand here, it becomes that V square will now become what? U plus what? AT. Remember your what? Expansion, right? U plus what again? 80. That's the meaning. You do it twice, right? You open up this bracket. So V squared is now equal to what? U times U is what? Huh? U times U is what? How can U times U be U? Is U squared now? Is it not? U times U is what? U squared is what? U squared. U times U is U squared. U times 80 is what? U 80. 80 times U is also what? U 80. 80 times 80. A times A is what? A squared. T times T is what? T squared. So this is something I'm saying that means 80 times 80 is A squared T what? Squared. That's the meaning. U80 plus U80 give us, we have to, x plus x is equal to what? Plus s is what? Is equal to what? It's not s squared. It's s times s, that is s squared. S plus s is what? 2x. Okay? You know, this has a coefficient that is 1. You cannot see it. This side has coefficient that is 1, but you cannot see. So that's why it becomes what? 2s. So if that's the case, that means u80 plus u80 is what? 2u80. Is it clear? So v squared is now equal to what? U squared plus what? 2u80 plus this one, s squared t squared. Are you following? I sure you're following. Please, if you're not, tell me, please. Don't keep quiet. Are we together? So v square is now equal to what? It seems I'm proving something else. I'm proving this third one. Oh. That's what I'm proving now. That's where this whole thing is leading us to. But let's see whether it's true or not. Let's not conclude for now. Let's see whether it's true or not. U square is equal to what? If you bring out, there's A here, there's A here, out together. There's U here. If you bring out this A, if you bring out A here, bring out A here. You want to introduce a bracket here. If you bring out A here and bring out A from here, and bring out 2, we have something like this. 2A in brackets ut plus t square over what? 2. Can you see the board? Please come to this side. I'm proving the second equation, the third equation, but no problem. See, are you there? Are you following? Here is 2a plus ut plus what? T square over what? 2. It's confusing, right? Okay, now if you use this 2a now to multiply everything inside here, you get this from here to here. If you use this 2a now to multiply everything inside this bracket, you get from here to here. Let's go. 2a times ut is what? 2a times ut is what? 2u80. True of us? Huh? Are you sure? Are you sure it's clear? Have you seen why I said that you should not play with your mathematics? This issue you're having here is mathematics issue. And I don't know where to start from. I don't know where to start from. This is just algebra. Algebra is algebra issue. I don't know where to start from now. Just let's see how far we can go. Maybe when we get to mathematics, we know what to do there. If you have 2x times y, it will give you what? 2x what? Y. We have 2x times y to give you what? 2xy. It's not the same thing we have been doing here since. It doesn't matter how they appear. So far, what is between them is products. It doesn't matter. See, x, y is something as what? Yx. Okay? It doesn't matter. That's something. Okay? But why I arrange it this way is because it is known that it is everything came like that. Okay? So it's something. So if you do 2a ut, 2a times ut is same thing. It has no meaning, right? So now if you use 2u, 2a to multiply this, these two will cancel these two. So 2 will go. We are left with what? At squared. See it here. So there should be a here. Think there should be what? A here. There should be what? A here, yes. There should be A there. Because you took one A outside. Okay? So there should be A here. So it becomes what? It becomes what? 2A times AT squared. It becomes, these two cancel these two, right? It becomes A squared T squared. Are you there? Are you there? Good. Are you there? So, in that case, now we now have, this is where we stop for now. I started, instead of me proving the second, instead of me proving the second equation, I started proving the third equation. And I have come to a point where I cannot go further. I will stop here. I didn't want to clean the bulb and start from second. I want to stop somewhere because I have not proved what I was supposed to put here. So I will stop here for now. We will not clean this one. We'll go and prove the second one. When we are done, we will not finish up this one, okay? So let's go to the second equation. That was the mistake I made. Let's go to the second equation. But did you understand how we got to this level? Now let's go to the second equation. Let's start the second equation, the journey of the second equation. So let's go. Before we go into the second equation, you need to understand the concept of average velocity. Average velocity and total distance covered. Okay? If you understand that, then you can prove the second equation. What is average velocity? What is total distance? Actually, total distance is simply what? Average velocity is simply what? The total distance over what? Time. So average velocity is what? Average velocity is what? Distance over what? Total distance covered over what? Time. Are you following? This is what we mean by average velocity is what? The total distance covered over what? Time. So what it means is that this implies that the total distance covered is equal to what? Average velocity times what? Time. Okay? But from what is down, let's substitute this average velocity with what should be here. When you hear average, it means if you have the initial velocity and we have the final velocity, that means average velocity is what? Initial velocity plus final velocity divided by what? 2. Do you know what is average? What is average? If you are given three numbers now and you are asked to find the average, what is it? By what? I'm asking you. What do you understand by average of numbers? So if you have three numbers now, or three letters X, Y, Z, and you are asked the average, what are you going to do? You have X, Y, Z, and you are told to find the average. What are you going to do? Eh? It's simply how many are they? One, two, three. Add them up and divide it by three. That's the average. Is what? X plus Y plus Z all over what? 3. This is the average. If we have two numbers, 40, 50, and you have to find the average. It's simply what? 40 plus 50. Divided by how many are they? 2 by 2. If you solve it, it will be the average of what? The numbers. The same thing now, average velocity. This v with bar. We have two velocities, initial velocity and what? Final velocity. So average velocity is just the sum of the initial velocity and what? Final velocity divided by what? 2. Because there are two velocities involved now. Okay? So the total distance is simply average velocity times what? Time. So average velocity is simply what? V plus what? U. Final velocity plus what? Initial velocity. All over what? 2. So total distance is simply what? This is average velocity, which is V bar. V bar is what? U V plus what? U. All over what? 2. This is average what? Velocity. So you substitute this for this V bar in this equation and get your total distance, which is what? Average velocity times what? Time. Is it clear? Eh? Are you sure? Is it clear? Talk now. Is it clear? So tell me where you're confused. Tell me. This one. So what's confusing there? Tell me. Let me know where the issue lies. Did you understand how I got this? How I got this now? Huh? Ask a question. Did you understand how I got this? Did you understand how I got this one? Huh? How? Is equal to what? Total distance over what? Time. Good. So we now made S this distance the solid of the formula. It becomes what? S is now what? Huh? Can you speak up? S is now what? Uh-huh. Over time. Can you make this S to insert the formula in this equation, please? I think I've taught you how to make straight a formula. Why are you talking like this again? Are you afraid? Speak up now. S is what? Did I teach you how to do cross multiplication? Huh? Then cross multiply now. What will be S? You do it in there. S is what? Huh? Don't you talk? Speak out. You speak out. Let me hear you. I can't hear you. You say what? S is what? Good. Average velocity times what? Time. Perfect. Did you understand what I explained about average velocity? Average of numbers. Remember we have the velocity, we have initial velocity now and the final Total distance now for a body that started from somewhere and ended somewhere had initial velocity and final velocity. So the average velocity is simply what? The sum of the initial velocity and what? Final velocity divided by what? 2, because we have two velocities now. So that means average velocity is equal to what? V, which is the final velocity, plus what? U, which is what? Initial velocity. All over what? 2. Good. So wherever we see in this phase here now, wherever we see this average velocity, we place it to what? This. We substitute. You know what I mean by substitution, right? Right? So if we substitute this V bar, this average, if we substitute V plus 2 plus V plus U over 2 for V for average velocity in this equation, it becomes what? That S is now equal to what? Tell me. Huh? Replace this thing with this thing now. What will it be? Huh? No, Judah, I don't know what is going on. I am not happy with what you are doing here. I will not lie to you. I've asked you what your issue is. You refuse to talk. Where do I start from now? Huh? Okay, look up. If you have y is equal to x, ax, a is 2, x is 4. What is y? What is y? Huh? If you have that y is equal to ax and a is 2, x is 4, what is y? Anywhere you see a, you put 2 now. Anywhere you see x, you put 4, is it not? So tell me, what is y? Is it jam that you are preparing? Are you sure? I doubt. I don't think you are preparing for, you are preparing for jam. I don't think so. I will not lie to you. I don't think so. I don't. We need to see after this class. Let me understand what is happening. With this thing you are doing, you are not ready for jam, and jam is next month. You are not ready for it. You need to sit down and start from scratch. Did you hear me? Take my advice. Am I completing? You need to start. Don't be ashamed. You need to start from the scratch. Take it step by step and come up. You need to start from the scratch. There's no magic about it. I hope you heard me right. Don't be discouraged, but it's a fact. You need to start from the scratch, from elementary mathematics and come up. If truly this thing you want to do, you want it, you need to calm down and start from the scratch. You can never jump step and succeed. Am I communicating? You jumped some steps. That's the reality. What I'm saying may be painful, but it's true. The lot of steps you jump to be where you are now, and you're preparing for jump, and you go to WAEC. No. It's not. It's somehow. Here, I tell people the truth. I don't care. I'll tell you the truth how it is, so that you can buckle up. It's simple now. This ax, put 2 here. You remember this is certain as saying a times x. It's not. Put 2 here becomes 2. X is 4. 2 times 4 is equal to what? 8. This is JS1 mathematics now. Is it not? That's why I'm surprised. It does a primary 6 now. That's why I'm surprised. At this level. That's why I'm surprised. You need to really do something about it, please. Anyway, the first step, you have taken the first step by coming for tutorial, but still, you are not, jam this year is not for you. You need to calm down, prepare yourself. unless you had maybe, I don't know, your plans. But if you truly want to write it yourself, you need to come up. Now come here now. If you stop, tell me, please, let's go. So S is now what here? I'm talking to you. S is now what? Yes, now S is V bar times T. So we see that V bar is V plus C over 2. So S is now what? Huh? What's going on here? I'm confused. Can someone talk to me? What's going on? Am I sleeping? Am I dreaming? Or is there anything I'm not doing right on this board? I'm confused. Can you keep that back and concentrate? I ask a question. I say V bar is equal to V plus C over 2. And what you want to substitute? Let's say S is now what? Over what? Uh-huh. Uh-huh. Why don't you come for mathematics classes? Why? This is simple mathematics now, is it not? Why don't you go to mathematics class? Why? Have you seen why I say you should come for mathematics class? Even if you don't write, even if you don't write, you wouldn't write it in JAMB. Come for mathematics class. This is just simple mathematics. So this is just simple algebra. True of us. So tell me what yes, you got this one right. So what next? I said that S is equal to V bar times T. Substitute this for V bar in this equation. What will it give you? All right, so look at it here. S is equal to what? V plus C over 2 times what? Everything here is V bar now. Is it not? Everything here is what? V bar. So put it, replace V bar with this thing now. Is it not? Huh? Are you still confused? No, tell me, are you still confused? Hey. Wow. So S is now this. Don't even know where I stop, sir. Hey. Please write down this. Let's so we can continue. Remember, I said I wanted to prove the second one and started proving the third one. So I got to this point. The thing now stop. I had to stop here and now move over to the second one. When I'm done with the second equation, I'll complete this third equation. Okay. So we arrived here. Any confusion on how we got here? So S is now equal to what? V plus U over what? 2 times what? T. So even if that is this, if this is the case now, next thing we need to do is let's open up what? This bracket, okay? Let's open up the what? The bracket, okay? So if you open it up, we have that S is equal to what? Vt plus what? Ut over what? 2. True of us? True of us? True of us? True, good. Now, but remember, from the first law of equation, we already know that V is equal to what? U plus what? From the first equation I prove here. V is what? U plus what? Huh? Good. U plus what? AT. So this is from the first equation. Now V is equal to U plus AT. So we'll now replace anywhere we see V in this equation. We replace it with what? U plus what? AT. Because V is equal to what? u plus what? At. V is equal to what? U plus At. So anywhere we see V, we replace it with what? U plus At. So let's go. So this simply means that S is now equal to what? U plus what? At. All brackets times what? T. Plus what? Ut. All over what? 2. Is it clear? Good. So let's continue. Let's open up these brackets. So S is now equal to what? T times U is what? T times, can you see what? T times U, we are opening this bracket now. T times U is equal to what? Ut. So we have Ut plus T times At is what? At what? Squared. Then plus what? Ut. All over what? 2. Okay? So let's say if you rearrange this thing, we have that S is equal to Ut plus what? At squared over what? 2. Look at it critically. Can you see the rearrangement? Please copy this so I can clean. Remember, I stopped here. I'll still come back here. So put down this one so I can clean. I have more space and continue. Una okwa m na-ata biko. Gịnị na-emezi? Gịnị na-eme? Hey, Jude. Why you go woman at Anyway, am I rushing? Am I rushing? Good though. No, tell me, am I rushing? I rushing, Munka. Is it I rush. So I should slow down. Hey, Jude. Are you done putting it down? But what I told you, look into it seriously. Yes, you need to sit down. Forget. Don't be ashamed. Just open mathematics again. Start from the beginning. It's very important to do that to help you. But the course you want to do is calculation course. So you cannot run away from it. You have to cool down and study mathematics well. Start from the scratch. Take it step by step. Don't worry. You give yourself like 1 year and be serious. Before the end of 1 year, you become very good at mathematics. I see the zeal, but I didn't expect that. I didn't know that it's like this. Can we go? All right, so let's go. So let me clean up this side. Let me clean up here. So let's bring up here, okay? So we have that S is equal to Ut plus what? Ut plus At squared over what? 2. Over what? 2. So this is now equal to what? Ut plus Ut is what? 2 Ut. Good. Remember what we did. Remember? Here is what? 2 what? Ut. Plus what? At what? Squared. Over what? 2. So S is now equal to what? 2 Ut plus what? At squared over what? 2. Okay? So we need to divide. We need to do what? Divide and if you carry out this division, are you aware that this is certain as saying 2 Ut over what? 2 plus what? At squared over what? 2. Are you aware? Are you aware? Good. So if that is the case now, these two will do what? Cancel those two. These two cannot cancel anything, right? True or false? So we have that S is equal to what? UT plus what? AT squared over what? 2. Hope you know that this over 2 is certain as half. Hope you know. Half of what? AT squared. Are you aware? So if you write it well, you have that S is equal to what? UT plus what? Half what? AT squared. This is the what? The third equation. True of us? True of us? This is the third equation of motion. I jumped it and went to sorry, second, God bless you. Not third, sorry. This is second equation. I jumped it and moved over to what? Third. If you look at this second equation, you see why I stopped here. Two of you look at, I want you to look at this second equation. You notice why I stopped here. Can someone tell me why I stopped here? Let me know someone that thinks. Which is S, right? There's no way I could have done anything when I don't even know what to do with it, because I've not proved what the second, I've not proven the what the second equation. So if you are done with the second equation, simply, if you go to this place, simply substitute this, put S here and get your answer. Because S is already what? UT plus what? Half AT squared. So put S here and get your third equation. Is it clear? Is it clear? Are you done here? Please put that one down first before we come over to this place. If you understand how this equation is derived, you will not cram anything. No matter how they twist the question, you can answer the question. No matter how they twist it, you can answer the question. But if you don't understand where this equation came from, that's how they twist the question, you become confused. You will not be able to do anything. Second equation. So let's conclude the third equation, please. So let's conclude the third equation. So now that we are here, now that we are here, remember that from the, sorry, okay. Now that we are here, remember that the second equation, from the second equation, we have that, remember, you can continue from here by saying, but S is equal to what? UT plus what? Plus what? Half what? AT squared. This is what? From what? Second what? Equation. Right? Right? This one is from where? First what? Equation. So what it means is that we will substitute S. Are we listening? What it means that we substitute S for UT plus half AT squared in this equation. Okay? So wherever we see UT plus half AT squared, we put what there? S. Right? So if we do it that way, we now come to this conclusion that V squared is now equal to what? U squared plus, we only have what? 2A here, right? So we put S here. We have what? 2A what? S. Is it clear? Is it clear? This is the what? The third equation of motion. I think we have tried here. So let's now look for question to solve. Unless you have any question to ask, then you can ask. If not, we go straight to solving questions. I know why I'm explaining that, because if you don't understand how this thing, you won't even know which one to use if you are given any question to solve. Sometimes this question emotion can be confusing. If you see a question, you become confused because you don't know how each of them came. So that's why I took my time to do all these things. And that's why I'm drilling you like this so that you know exactly how to do it. Because if I do everything here on the board for you, you forget it easily. You see the way I drilled you today. Anywhere you see this question, you can solve it. Get me. Three of us. Ask.
Like, this question, question two was derived from question one.
Equation what?
Then that equation two that we solved, um, this, okay, this third equation, just like this equation one is this in driving equation one and equation one and two
Uh,
is this in driving. Then equation where is it derived from?
she came late and she asked me where she came into class. She want to use title. I said where I came from. Jude, help her. Where did you get it from? She was like, yeah. Hi. She came late and she asked me where I got it from. Ah, smart kid. Smart kid. What did you even comment this? What did you comment?
I don't know I want to go to church, but that is like church now.
Okay, you wanted to go to church. Okay. Uh, from where? Okay, you want to so you want to solve it on the board. Huh? Huh? Talk now. You you want to solve it on the board? Yeah, believe me. No, if you want, fine. Come and do it. No problem. If you want to, come and do it. I like that. Come and do it. Oh yeah, fast. Come and do it now. I like that. That's good. Come and do it. Do it. Do it here. Anywhere. Good evening.
The first equation.
Mm-hmm.
So so equals to hours, yeah, plus 80.
Mm-hmm.
Equals to 80 plus 1.
Mm-hmm.
What can I see here?
Today henceforth, anybody that come late to my class, I will not listen to the person. I want to make it an official announcement now. Hope you listen to me. Today henceforth, if you come late to my class, I will not go back. I will not do it. If that thing is important to you, go and watch it. Am I communicating? It's not a good thing when you stay at home and face your private thing, private affair that is more important to you. Then after that, now you come back to class and want us to go back. It's wrong. It's what? Very, very wrong. Am I communicating? Eh? Good. So before you think of coming late to class, ask yourself what the implication. If that class is very important to you, then come on time. Okay. So let's look at questions. Let's look at what. Let's see. Remember our reference book for today is New School Physics for Senior Secondary Schools by MW Anyakawa, PhD, 2016 edition. So we'll pick some questions from this textbook and after that we'll now go over to past questions. Let's see how far we can go before 6 p.m. It's 5:26 already. Okay, let's look at this question. Put this question down. No, come and write it on the board. Come. Junior, come and write it on the board fast. Yeah, this one. Okay. Write this one. Write this 2.1, 2.2 first. Okay.
Okay,
Let's
2.2 first.
no, I mean write 2.1 and 2.2. Let's see. Let's when we are done with that, we can write more. Take the marker. Okay, let's look at these questions on the board. You can put it down first. You're done, right? All right, let's look at these questions. The first question says a bus traveling at 60 kilometers per hour accelerates uniformly at 5 meters per second square. Calculate its velocity after 2 minutes. Calculate its velocity after 2 minutes. See, there's something I want to let you know on how to solve questions like this. The first thing you should do after reading the question, try to outline the parameters given in the question. Okay? Each of these, look at these equations of motion. First one says V is equal to U plus what? AT. S is equal to what? UT plus what? Half AT squared. V squared is equal to what? U squared plus what? 2AS. Look at this equation. Look up. The first equation has no distance. True or false? True or false? Eh? Good. The second equation has no final velocity. True or false? The third equation has no time. True or false? True or false? Good. Each of them has something they don't have. So whenever you are given a question, try to list out what you are given, the parameters given to you. When you list them out, you start looking for the one that is not there. Apart from the one you are looking for, you say you check out the one that is not there. If there's one that is lacking, then you do able to know the right equation to do what to use. Am I communicating? So now let's look at this first question. As we read it, I will what outline the what given parameters. Solution. The first one says, are you following? A bus traveling at 60 kilometers per hour accelerates uniformly at 5 meters per second squared. Calculate its final velocity after 2 meters. The first velocity there, which is what? The initial velocity, right? U is what? 60 what? Kilometer per hour. Are you following? Then they say that it accelerates what? Uniformly. They say that it accelerates what? Uniformly, right? So that means they gave us what? Acceleration, right? Which is what? 5 meters per second what? Squared. What next did they give us? They say we should calculate the second velocity, which is the final what? Velocity. They may not write final velocity. They may not write final velocity for you, but you should know from the question that is what? The final velocity, which is v. We don't know it, right? And they gave us time, which is what? After 2 minutes. Time is what? 2 minutes. Look at this equation. Look at these parameters. Which one is lacking? Huh? Which one is lacking here? No one now you should find v. I mean the one that is not given. That is the lacking that you don't need in the equation. Huh? Distance, right? So if that is the case, what equation here doesn't have the distance? So simply use what? Simply use the first equation to solve the thing. Is it clear? Just simply use the first what? Equation. Okay? Distance, but the first equation lacks what? Distance. So use the first equation to solve what? This. So that's what we are going to do. But before you start solving, please look at this parameter, look at this unit, please. Oh, if you see how they gave you, they scatter different units for you. They must be in the same units. If you want, this one is kilometer per hour. This one is meter second. Move it to SI. This is kilometer, this is meter. Move this kilometer to what? Meter. Okay? Move it kilometer to what? Meter. Move this hour to what? Second. Move this minutes to what? Seconds. Then you can start solving, okay? Is it clear? So they will be in the same thing with this acceleration, okay? So to do that, let's move this one to, this is kilometer per hour. We want to move it to meter per second, okay? Let's go. Hope you know that this 60 kilometer per hour is the setting as saying 60 kilometer over 1 hour. Hope you know. Are you aware? That's the meaning. Are you aware? So we have arrived at somewhere. Simply convert kilometer to what? Meter. Convert hour to what? Seconds. And you're good to go. Let's do it. How many meter make 1 kilometer? So 1,000 watts. Are you following? 1,000 meter make 1 kilometer. So what it means that anywhere you see kilometer, we put what? 1,000 meter. So this is certain as saying 60 times what? 1,000 meter. Three of us. Kilometer is what? 1,000 meter. Three of us. Are you clear? All over. This is hour, right? How many seconds make 1 hour? 60 seconds make 1 minute. 60 minutes make 1 hour. So how many seconds make 1 hour? It's not 120. It's 60 times 60, please. See it now. If 60 seconds make 1 minute, okay? Watch out. If 60 seconds make 1 minute, so here we have minutes, we put 60. Two of us. Because this is certain as saying 60 times 1 minute. Hope you know. Are you aware? Can you start that in your function and look up? Professor, your eyes are there. Look up. Because I'm about to do something like that. By the time you raise your head, you become confused and you start asking questions. Look up. I want to show you the simplest way to do this thing. We agree that 60 seconds is what? 1 minute, right? And 60 minutes is what? 1 hour. Are you aware that this 60 minutes is certain as saying 60 times 1 minute? Two of us. Huh? 2 times 1s, 2 times 2s is equal to what? 4s now. So 2 times s is equal to what? 2x. Are you aware that this is certain as say 1s? So 60 times 1 meter is what? You said you did here now, eh? Okay, it seems it takes you time to process information. But don't worry, let me calm down. This thing you did here, eh? Let me go back again. 2 times 2s is equal to what? 2 times 2s is equal to what? 4s. 2 times 1s is equal to what? Because this is 1, right? But you don't put 1 in front of s because you don't put it. But we know that 1 is there. So 2 times s is what? So 60 times 1 meter is what? 60 meter. Is it not? 60 meter, right? Is equal to what? 1 hour, right? Right? So 60 times 1 meter is equal to what? 1 hour. Remember that 1 meter is 6. Sorry. Sorry. I will say meters here. Is keep quiet. Minutes. Minute, not meter, please. Minutes. Minute. Oh, it's not meter. 60 minutes, please. God, my brain is firing. This is 60 what? Minutes. So 60 times 1 minute is what? 1 hour. Two of us. So wherever you see 1 minute, you put what? 60 seconds, right? Right? Because 6 seconds is what? 1 minute. So if you put it, it becomes what? 60 times what? 60 what? Seconds. Two of us is equal to what? 1 hour. Right? So what it means is that 60 times 60 seconds is equal to what? 1 hour. So we put it here. We have 60 times what? 60 seconds. Is it clear? Is it clear? Are you sure? So we're good to go. So 160 will cancel what? 60, right? 10 will cancel what? 10. So we have 100 over 6 meter per second. Two of us. We can go further. 2 divided 6 is what? Is what? 2 divided 6 is 4. 3 is what? 3. 2 divided 100 is what? Good, 50. So here is what? 50 over 3 what? Meter per second. Do you agree with me? Do you agree with me? So we have moved 60 km per hour to what? Meter per second. We'll stop here. This one is already meter per second. So meter per second square. So we are not converting anything here. Two of us. Minutes. Let's move minutes to what? Seconds. How many minutes make one? How many seconds make 1 minute? Answer me. Seconds make 1 minute. Look at what looking at you on the board here. How many seconds make 1 minute? I say 120. So 60 seconds make 1. Hope you know that these 2 minutes is certain as saying 2 times what? 1 minute. Hope you know. Hope you know. Are you aware? Are you aware? You just said to do here now. Why do you here like this? You are the one that told me that 2 times 1s is equal to 2s. So why do you here like this? Is it not? Are you sure it is? You're not confident in it, in what I'm saying. It is. Without confidence, right? So I'm trying to teach you how to do this easily without wasting your time. 2 times 1 minute is 10 times for 2 minutes. Hope you know. So you replace, but 1 minute is what? 60 what? Seconds, right? So you replace this 1 minute with what? 60 seconds. So 60 seconds are saying 2 times what? 60 seconds, right? Which is what? Which is what? 2 times 60 is what? Keep that in. 2 times 60 is what? 120, good. 120 what? 120 seconds. We are done converting. So now let us now calculate. What equation did we agree that we will use here? First what? Equation. So V is equal to what? U plus what? 80. So V is now equal to, initial velocity is what? 50 over what? 50 over 3 meter per seconds, plus acceleration is what? 5 meter per second squared, times time is what? 120 seconds. Okay, so let's 5 times 120 is what? 5 times 120 is what? So V square is what? Sorry, V is what? 50 over 3 meter per second plus 5 times 120 is what? Huh? Huh? Is what? You are doing at 600. That means you're not sure of what you are doing. Please be confident in yourself, please. What's the answer? 560. It's 560. Wow. Is what? Is what? It's 600. So look up. Before this can be added to anything, they must be in the same units. So this second here will cancel 1 second here. True of us. So this second here will cancel what? 1 second. So we are left with what? Meter per second, right? So 5 times 120 is what? 600. So we have 600 watts meter per second. I'm also teaching you how to handle units. Very careful in handling units, right? So let's add up this thing now. Let's add up this. So let's shift the unit by the side, okay? Is that now saying 50 over 3 plus what? 600 meter per second. Is that clear? Is that clear? Good. So this is now equal to what? So let's now add up, okay? Can you see the board? Can you see the board? You cannot see the board. I don't understand. When I was writing it, you are copying something here. This one is blocking your view. See where the eye is this? Not here. Be here first, okay? So you understand what you are doing here. After you can copy. Are you following? So let's add up now. Let's find the SCM. Here is what? Here is what? We have what? 3, right? Right? This is 1. Let's go. 3 divided 3 is what? 1 times 50 is what? 50 plus 1 divided 3 divided by 1 is what? 3 times 600 is what? 3 times 600 is what? 1,800 or meter per second. So this will give us what? 1,800 plus 50 is what? 1,850 over what? 3 meter per second. So if we break this thing down now, Because of time, you can punch a calculator here. So we don't waste time. You know, this is not normal jam question. Am I complicated? That's why these numbers are like this, okay? So let us issue 600 and something, but let's just punch it. 6 guinea, 616.67. This is not jam standard, because jam will never give you a question you need calculator. I keep saying this, okay? This may be YX standard. It's okay, but I just picked it from the word textbook. But jam will never give you a question you need calculator to punch. Like. So for us to save our time, let us. You say we got what? 616 point what? 0.67 meter per second. That's the answer. 616 point what? 67 meter per second. Is it clear? Where? Here. Eba. It's mathematics now. Find LCM of this thing. Do you know how to do LCM? I do it now. I get the answer. I do it there. 50/3 plus 600. Do it. This is not physics. So this in here is not physics. See, we have physics ended somewhere here. Any other thing I see is just mathematics. Just add and get your answer. Unless you don't know how to do it, tell me. If you know, do it. It's simple. Is it clear? Okay. Our time has elapsed. I think I want you to try this second one at home. Okay? Okay? All the things I will tell you to try, you come back and you will not show me. Where's the assignment? Where's the English assignment I told you to? Okay, we'll bring it, let me see. Jude, where's your English assignment? Bring, let me see. You not come with it. You're rushing. Okay. All right, thank you very much for your attention. Any question? I thank you very much for your attention. See you tomorrow. Sorry, Sunday. All right.